we are given a function f, which is a cubic function. Right? How do we know that? Well, the highest power of x is cubed. We also know that it is a positive cubic because the coefficient of x cubed is, in this case, positive 1. So it will look something like that. Beautiful. And we're asked to find the gradient of this function when x equals 4. Alright, so it's asking for the gradient. So in calculus, we have the gradient function. Right? To get that, we need to take the derivative of f of x. We need to differentiate it. And to represent that, we use f prime of x. So that's the first derivative of the function f. And taking the derivative, so the derivative of x to the power of 3 becomes 3 to the x to the power of 2. And so the rule is we take the power, we multiply it out the front, so that's why we get the coefficient of 3, and then we reduce the power by 1. So it goes from 3 down to 2. Awesome. We can apply the same rule to minus 6x. Now, when it's just an x, remember that it's to the power of 1. So let's do the same thing. So 1 times minus 6 gives minus 6. Now we have x to the power of 1 minus 1, so we're subtracting 1, which gives to the power of 0. Now how else can we write x to the power of 0? Right, anything to the power of 0, apart from 0, is 1. So minus 6 times 1, which is minus 6. Another shortcut, if you'd like to remember it this way, is the derivative or the gradient of any constant times x is just that constant. For example, the derivative of 2x is 2. The derivative of negative 100x is negative 100. But the rule does work as it should. And finally, the derivative of plus 2. So two ways going about thinking about this. Firstly, the easy way is the derivative of a constant is 0, right? Because it's constant, it has no gradient, it's not changing. So on a graph, if we were to plot y equals 2, we can see that it's a flat line. Its gradient is 0, so its derivative will be 0. Alternatively, we can still use the rule, but what's actually hidden next to this 2 is x to the power of 0, right? Because x to the power of 0 is 1, so it's kind of like it's not there. Using the rule, 0 times 2 gives 0, right? And we're left with plus 0 that way as well. Cool. So far we have calculated the first derivative of the function. Right? We have differentiated f of x. And that plus 0 we don't actually need to write. Now, rereading the question, it's asking us to find the gradient at a specific x value. So what we need to do is use that x value in our gradient function to find the gradient at that x value. So substituting in 4 in for x, we get 3 times 4 squared minus 6. What's that? 16. 4 squared is 16 times 3. What's that? 48. 48 minus 6 is 42. So the gradient of f of x at x equals 4 is 42. Alright, and getting that far would get us an achieved, right? The derivative and the gradient. I will show you how you can verify it on your calculator, so stick around for that if you like. Otherwise, see you next time. So on our calculator, we can go to graph. And now, when you're sitting an exam, your calculator is reset, so you do need to turn the setting on. So Shift Setup, and you see derivative, turn that on, so F1. So that was Shift Menu So go to the setup, turning derivative on. Now you can put in any function. In this case, we'll put in the one we're given, x cubed minus 6x plus 2. We can hit draw, and as we expect, it is a positive cubic. So that looks good. Now we can hit F1, which is trace, so F1, and see how it gives this x and y value. It also gives dy by dx. Now that is the derivative. It is the gradient. So if I hit 4 and hit execute, when x is 4, y is 42, and the derivative, actually coincidentally, is also 42, which is what we got. So that's a quick way you can check on your calculator. All right, bye.